Hello. I don't know what you guys can see right now because I'm trying to find the right screen. There we go. Anyway, here we go. So our warm up has more circle stuff. This one isn't something we've specifically done, but I think with everything we have done, we should be able to figure these out. The warm up says that AB is the diameter and that arc AC is 21 degrees. Well, if we have a diameter, we know that either direction we go from one point of it all the way around to the other is going to be 180 degrees. The semicircle is what the diameter kind of helps to create. So we can take that whole thing, the 180, and take away this part to find this arc. And then we also know that the central angle is equal to the arc. So that's the game plan. Doesn't want to show up. Okay. So we're going to take first 180, subtract the 21 to get this arc CB. Will get us the arc. So arc CB is 159. So I'm going to actually erase so it's not too confusing. So now this arc alone started with the whole thing, which was 180 diameter. Now we've got this arc at 159. And again, the central angle is equal to the arc. That's the angle we're looking for. Angle CDB is 159 degrees. Sweet. The next one is actually pretty similar. Again, we have a diameter LN. The same thing. This whole thing is going to be 180. Take away the part we don't want, and we'll find the arc we do want. So I'm going to let you do the subtraction this time. Take away the part we don't want, and we're going to be left with our answer, arc MN. It's kind of quick Monday, so I'm going to let you do some of the subtracting and whatnot. I'll just set up quite a few of the problems. And we're rolling. We're going to do, the pens together here, 5.5 today. Actually, before we jump to the worksheet, let's look at some notes that I posted for you. And they're a little bit overwhelming, but we're only going to do a couple of things today. Much of this we've already done. So here's general circle information, at least these four. I'll let you read through. You really should write the notes in your own writing. I have a blank template for you to write all of this down on. I realize some of you won't do that. That is my strong recommendation. These are things we're going to get to in the future. We're not there yet. We have already talked about these 2, 3, and 4, I believe. If we haven't talked about this one, we will. I believe we have, though. Yeah, we did this one on Thursday, Friday. So we've done all of these. Again, you're going to write these on your own time. Or during class, if you come live, then we'll have time in class as well. Today, again, this is overwhelming. There's so much here, but don't stress. We're only going to do 2 today. We're going to do the inscribed angle theorem and the intersecting chords angle theorem. So first of all, what's an inscribed angle? I was looking to see if they have it defined up here. They don't. An inscribed angle is 2 chords that share one endpoint. So we have chord BC and chord AC, and they share endpoint C, which has now become a vertex of an angle. It's inscribed. That angle is inscribed in the circle. And this says the measure of an inscribed angle is simply half the measure of its intercepted arc. Its intercepted arc is this arc AB here. So if we're looking for the angle and we're given the arc, we'll just take half of the arc and we have the angle. However, if we're given the angle and we need to find the arc, obviously we would double it. Since the reverse is half, we would have to double it. We're going to practice that. And then we have intersecting chords angle theorem. This one's a bit more complicated, so here we go. The measure of an angle whose vertex lies in the interior of the circle. So we've got an angle here. They marked it with red. this angle is inside the circle. It's not the center of the circle. I mean, it could be, but it's unlikely that the center of the circle would be much easier because that's a central angle and it just equal to the arc. So this is not the center. Again, vertex lies in the interior of the circle. It's equal to half the sum of the measures of the arcs. Oh, this is wordy. Intercepted by it and its vertical angles. Wow, like what? It's not that hard. It's hard to read because it's just a lot. But here it is. If we have this arc and we have this little arc over here, these arcs are kind of created by these two intersecting chords. We add those guys up and divide by 2. And that'll get us the angle here. And by the way, it would get us this angle over here too, right? Because those are vertical angles. So it kind of doesn't matter which side you're on. All right. Oftentimes that's like, what is happening? That's too confusing. And then we start to do it and it's much less confusing. So let's do it. And you can always look back at your notes. I don't expect you to write them now. Of course, this is recording. You could pause and write those notes first if you want. But we're going to dive in. What's the measure of angle? Here, I'm going to highlight the angle for us. Oh, I don't want to use that. We're looking for angle B, A, C. That's this angle here. It's an inscribed angle, and we just learned the inscribed angle, angle BAC, is 1/2 the intercepted arc. So half of 65 is 32 and a half. I think Apex works in decimal more than it does leaving it as a fraction. Okay, that's it. Half of the intercepted arc. The inscribed angle is half of the intercepted arc. Well, this time we have the angle, so we're going to have to double it to get that arc, that intercepted arc. So we're going to take, we're looking for E, arc EF, and we're going to have to double the angle to get the arc. So we get 170. Arc EF is 170. All right. I'm going to let you do the rest of that. No, not the rest. I'm going to let you do 3, but let's do 4, and then I will let you do the rest of that page for practice. It says, be careful because 4, 5, and 6, you know, we just learned how to find this arc right here, but that's not the arc they're asking us for. They're asking us for MLN, this major arc. So we're going to find this arc. I'll call it X for a minute. And then we'll use that information to find the major arc that they really want us to find. So X is, again, double like the last one we did. If we have the inscribed angle, we'll have to double it to get the arc. So X, that arc, not the one we need. I mean, it's the one we need. It's not the one we're ultimately trying to find. We're going to get 110 degrees. But that's not our answer. That's going to help us find the answer. This is just a portion of the full circle. The full circle, of course, is 360 degrees. So to get MLN, that arc, we're going to take the 360 degree total circle and take away that portion we just found. And then we'll get MLN, arc MLN is 250 degrees. Sloppy-ish. All right. So read carefully when you're taking your Apex quiz. What are they asking you for? Because we want to jump straight to this and call it good. And I guarantee that's going to be one of your answers on the multiple choice on the Apex quiz. So be careful and read slowly. All right. So that's inscribed angle theorem. And now we're going to the other theorem. This one's quite a bit more complicated. This is this guy here, the intersecting chords angle theorem. It's going to be half the sum, it being that angle inside, is half the sum of the arcs, half the sum of the arcs. Here we go. So we've got 2 arcs. We're looking for angle XVV. y, this guy here. And for that matter, it could be this one. They're the same. They are vertical angles, but that's the one we're looking for. So to find angle XVY, we take half the sum of the arcs. The arcs are 86 and 78. All right. Sorry, I don't trust my recorded, even the simple stuff. 164, when we add those up, we're going to get angle XVY. Half of 164 is 82. Angle XVY is 82 degrees. And again, they might have asked us for this angle. They're vertical, so they are the same. Okay? Now, what if they're asking us for one of the arcs? It's really the same setup. This time we're given the angle where, let me open this up. Last time we were looking for the angle. This time we're given an angle, and we're looking for the arc, AD. So this is the goal. We're going to do the same formula. We'll just put everything in place. This time we'll have the angle here. Oops, can't see that. We'll have the angle 55 is equal to half the 30 plus the unknown arc. Maybe temporarily we'll call that x. We just put everything in its proper place. This time we know the angle. So we'll start with that. The angle is 55 is 1/2 the sum of the arcs. The arcs are 30 and x. So they're the same type of problem, but looking for different pieces of information using the same formula. So we're going to distribute this half. We have 55, not doing anything to that yet. Half of 30 is 15. Half of x is half x. Of means multiplying. Now we're going to subtract, and we get 1/2 x equals 40. To get rid of a fractional coefficient, I think I'll change colors to emphasize. How do I get rid of a fractional coefficient? Multiplied by its reciprocal. Well, that's the same thing as plain old 2. And so, squeeze it in, x is 80. But x was that arc, so we might say AD, arc AD is 80 degrees. So that one gets, you can't see it, that gets a little tricky. Just, rewind and play the video again and, listen carefully about putting things in their proper place. Comparing these two again, we have the angle. This time we're given the angle. This time we weren't. Equals half the sum of the two arcs. This time we didn't know the arc. This time we knew both arcs.